Okay, moving on with geometric concepts, we have in the realm of matrices and determinants. Okay, we have next, okay, we have testing for whether we have specified points are in the same plane. And for the test for coplanar points in space, okay, we have 4 points are coplanar if and only if the determinant that includes their coordinates along with 1 as the exclusive value in the last column is equal to 0. So you have in the array, okay, so you have x1, y1, z1 followed by 1 at the top. Next you have the second set of coordinates followed by 1. Then you have the third set followed by 1, and likewise with the fourth set. And let's say that if you have an array of 4 points to see if they are in the same plane, meaning coplanar, and we have looking at whether 0, 0, negative 2, 0, negative 2, 0, 1, 1, 0, and 2, 1, 2 are coplanar. So for the matrix A, okay, so you have like your first x, y, and z followed by one set. You have 0, 0, negative 2, 1. Then we have for the second set 0, negative 2, 0, 1. Third set we have 1, 1, 0, and 1. And then we have 2, 1, 2 followed by 1. And crossing over to the determination of the value of the determinant. Okay, so what I want to do here, like say, like to have 1 as the value in the upper left-hand corner. And so what I can do here, like the 1, 1, 0, 1, if I want to place this at the top, I can interchange the first and the third rows. And each time you interchange in looking at finding out the value of a determinant, you're going to have a sign change. Okay, so you're going from a positive to a negative upon the interchange. So for each interchange, you go from a positive to a negative and vice versa. So after this interchange, so we have 1, 1, 0, 1 at the top, and now it is 0, 0, negative 2, 1 in the third row. And for what I have for the first column, I got 1, 0, 0, and I want to make this 2 at the bottom row into a 0. Okay, so making this first element 0, so I'm going to subtract the first row elements multiplied by 2 away from the last row. So subtracting twice R1 from R4. So the last row changes over to 0, negative 1, 2, and negative 1. And so the first column we have 1, 0, 0, and 0. Now looking into the next column, okay, if you notice we have going down, we have the second row, we had the leading coefficient negative 2, and I want to display this as a 1. So I can factor out the negative 2 from the second row. And if I do this, and we have like the negative of negative 2 is going to be a positive 2. And the second row changes over to 0, 1, 0, negative 1 half. And I want the second column to be 0, 1, 0, and 0. So I'm going to make some adjustments here. And for what we have in this particular case, so I'm going to subtract the second row elements from the first row, and also add the second row elements to the last row. Okay, and so I'm going to make the 1 at the top and the negative 1 at the bottom into a 0. And upon doing so, so you still have 2 out at the front, and changing the second and the last rows after these operations. Okay, so we're going to have in this particular case, all right, so we're going to have for the first row as well as the last row. Okay, so I have 1, 0, 0, 3 halves, and I have 0, 0, 2, negative 3 halves. And looking at what we have now, so I got 1, 0, 0, 0, 0, 1, 0, 0, and I want to have 0, 0, 1, and 0. And the negative 2 that is in the third row, I want to make this into a 1, so I can factor out negative 2, and doing so, the leading coefficient in front, which we have at 2, is going to change over to negative 4. So modifying the third row, I have 0, 0, 1, and negative 1 half. And now at this stage, I can make the 2 in the last row into a 0. And I can do this upon subtracting twice the third row elements from the last row. Okay, and so doing so, the last row is going to change over to 0, 0, 0, and negative 1 half, since 2 minus 2 is 0, and negative 3 halves minus what's going to be negative 1 is going to be negative 3 halves plus 1, which will be negative 1 half. And I want the negative 1 half to become 1. And so what I'm going to do here, all right, so I still had the leading coefficient at negative 4, which is going to change for I'm about to factor out negative 1 half from the last row. And doing so, you got negative 4 times negative 1 half is going to be a positive 2. And the last row changes over to 0, 0, 0, and 1. And just for the follow through, like taking the first row, deducting 3 halves of the last, and the second row adding 1 half of the last row, and the third row doing likewise, I'm going to end up with the identity. We have 2 times, and again for the array of ones amongst the zeros. Okay, so the ones running diagonally and everything else being 0. Okay, this portion goes to 1, and 2 times 1 is equal to 2. And since the value of the determinant does not equal to 0, it turns out that all these points are not coplanar. All right, now in looking at the equation of a plane, and if you're taking Calculus 3 or have taken Calculus 3, you've looked at some level of methodology in looking at the determination of the equation of a plane, especially if you have a plane going through 3 distinct points. And we have an equation of the plane that passes through distinct points, okay, where we have like the first, second, and third layout or sets of x, y, and z values. And we have it that the determinant that you attain is going to be set equal to 0. So we'll be looking at the necessary coefficients for the x, y, and z terms to be equal to 0. Okay, and so we have for this array, okay, again, we have at the heading have x, y, z, and 1. And again, for the following rows, you had the first, second, and third sets of x, y, and z values, and each set we have followed by the number 1. Okay, and let's say that as an example, if you're looking at determining the equation of the plane that passes through 169, 493, 538. So 169 is x1, y1, z1, 493 is x2, y2, z2, and 538 will be x3, y3, and z3. And looking at what we have for the matrix, again, you have the heading x, y, z1, and again, you have the sets of x, y, z values followed by 1, and looking at the value of the determinant. Okay, and for the manipulation here, okay, I want to have it to make this made as determinant operation friendly as much as possible. And what I want is for the second row, I want what is immediately underneath x, y, and z to go to 0. Okay, and what I can do here is that in correspondence to the last column, like 1 minus 1 is 0, 6 minus 6 is 0, 9 minus 9 is 0. So I'm going to be taking the value of each item in the last column and subtract directly from the first column, and then take 6 times the last column values from the second column and 9 times the last column values from the third column. And if I do this, okay, so the top row will have x minus 1 and y minus 6, and I'm going to have z minus 9. And if you notice, okay, we have with the second row, I have 0, 0, 0, and 1. And okay, now 4 minus 1 is 3. 9 minus 6 is 3. 3 minus 9 is negative 6. And again, you have followed by 1. In the last row, you have 5 minus 1 is 4. 3 minus 6 is negative 3. And 8 minus 9 goes to negative 1. And then again, we have followed by 1. And okay, now just looking at the minors and the cofactors in the setup. And again, you have your alternating pattern, plus, minus, plus. And so you have plus x minus 1 minus the quantity of y minus 6 plus that of z minus 9. Now mention, I did not include 1 because that determinant part is automatically going to go to 0. And looking at what we have in the array, if you notice you have x minus 1. If you notice you got 0 is negligible, 0 is negligible. And we have plus 1 times the minor that is left over. So you have x minus 1. So you're just kind of like covering up 1 in the upper right-hand corner. You have exposed, you have 3, negative 6, negative 3, negative 1. And I got minus the quantity of y minus 6. And guess what? You got negligible, negligible. And we have with the first row, third column, minor. Okay, set up, we have 3, negative 6 for negative 1 exposed. And then we got plus the quantity of z minus 9. And guess what? So we have 0, 0, 1, 3, 3, 1, 4, negative 3, 1. And again, with the first row, third column, minor setup. Okay, so we have exposed 3, 3, 4, negative 3. And for what we have in the follow through, okay, so you have x minus 1. And for the 2 by 2 determinant value alongside it, okay, this is going to be negative 3 minus 18, which would be negative 21. And then we have alongside the subtraction of the quantity of y minus 6, okay, the value of this 2 by 2 setup, okay, the determinant value is going to be negative 3 plus 24, which would be 21. And then we have the quantity of z minus 9, and here we have negative 9 minus 12, which would be negative 21. And again, this equation setup is going to be equal to 0. And for what we have in the follow-through, okay, so we want to have, upon distributing, we have negative 21x, and what is going to be minus 21y, minus 21z, and the product among the constants and moving to the other side, okay, you have a combined total at negative 336, and then we have with division by negative 21, okay, we have in simplified form, okay, you can say that the equation of the plane will be x plus y plus z is equal to 16.